Electric Auto Shop is now working with Switch Vehicles to produce Chassis Lab. This is an open source platform for instruction of electric vehicle drivetrain technology and parts component integration on an open platform that can be used in any classroom.
Okay, I'm Peter Oliver. My partners and I have created what we call the Switch. It's an open source three-wheel electric vehicle. It's designed to be a real fun car to drive and a really fun car to build. It's open source, so we can put in lead-acid batteries or lithium batteries. We can build it with an AC motor, we can build it with a DC motor, but it can be built on the ground and really be constructed in a single semester, which is something that's really important for us. It gives students a real experience of building something and having the satisfaction of actually driving it around and getting it done in a fairly short period of time. You can drive it on any of the roads in California. In most states, it's with a larger DC motor or AC motor that's freeway capable, speeds up to 65, 70 miles per hour. One of the things about building electric cars that I found in a typical classroom was that only 2 or 3 students at a time seemed to be able to work on the vehicle. There's just so much space. When you're working under the hood or you're working in the rear. With our vehicle, we can have 2 or 3 groups of 2 or 3 students doing different functions at the same time. Up in the front, we have a battery box, so you can have people working on the cells, monitoring the BMS. We have a low voltage system here that people can access. We have in the rear, the motor can be assembled. Underneath the seats, we have the whole electronics box, which can be built outside of the vehicle. So again, 3 or 4 students could be working on that concept, and then it can be assembled into the vehicle. And again, you can work in teams. And students would have an opportunity to share what they learned about relays and fuses and terminations and show the work that they did. And again, this drove home communication skills. It made students pay attention when they were working on a team so they could explain what was going on. And it gave them a real sense of satisfaction when they got it done and were able to explain it to the other students. The beauty of this is you can test it on the bench, and then you actually install it in the vehicle, and you can use this as the laboratory, and you can demonstrate it really openly to everybody. People can stand around and they have good views of everything that's going on in the vehicle. Since we designed it as an open source vehicle, we can use the AC system or we can use the DC system. You could actually, with a minimal amount of expense, build a DC vehicle, show everybody how DC works, and in the next semester you could actually use the same vehicle and a lot of the same components to implement an AC system. It's important for students to learn the pros and cons of each kind of spade and connector, and also how to crimp and solder properly and how things can be crimped and soldered. So that's a real good learning tool there, and it's colorful and exciting, and kids kind of like it when they can turn the key on and see the relays actually function properly. high voltage cable in orange conduit, which is the international standard for high voltage, and it goes into the battery box. Students learn about high voltage cables, they learn why we keep them together, and they learn how to handle high voltage with respect and caution. We can change these sprockets to change the performance of the vehicle. If you want to go a little faster for shorter distances, we change the gear ratios, and that's something that could be fun and interesting for students to understand the ramifications of changing gearing. We connect here. We have a DC motor in place in this particular vehicle. We have the ability to put different size motors in there. This particular vehicle is designed to run at 96 volts. It has a 100 amp hour cell, so it has about 10 kilowatt hours of energy, which would power this particular vehicle for about 50 miles. Each of the cells has on it a BMS board. BMS stands for Battery Management System, and you can see that they're functioning because the little lights are blinking. And that simply says that the cells are connected to the BMS computer located in the low voltage module. So students learn all about this. They learn about how to charge cells. They learn about why it's important to keep the cells at the same state of charge, and how we do that and why.